welcome to Tiny Code Christmas Day 11, the third dimension. And today we're going to be taking a look at how we can build this. So this is the end goal for today, and it is a 3D spinning voxel cube, and it is made up of these circles which have this nice little bit of shading on it, and you can see that there's a plasma effect applied to the points on the cube based on their coordinates on the screen. Now that last bit is going to be left as a challenge to you, and we are going to work in this video to build up to this, which is the 3D cube with the voxels and the rotation and no plasma effect. So this today is as much of a challenge as you want it to be. The video will explain this effect as you see it on the screen fully, but if you want, you can stop the video at any time and give yourself an extra bit of a challenge. Now today I'm only going to be explaining the code in PICO-8 because it's just easier to fit it on the screen, and then I'll be covering PICO-8 specific stuff in the PICO-8 section, but there's not going to be two completely separate sections today. So let's take a look at our setup here. So I am aliasing sine and cosine, I am clearing the screen, I am assigning variable time, and I'm assigning time to a variable t. I am creating a point here, and this is our first introduction to Lua tables. And basically what a Lua table does is it allows me to combine these three values into one entity. So, and then I can refer to that further on down as point.x and point.y and point.z when we get to it. So it allows me to group these three variables together essentially as one unit, and I'm storing that in point. So it'll allow me to store x equal to 10, y equal to 10, z equal to 10, and use them and modify them at different points throughout my program. So what we're going to do first of all is print out this point to the screen. So we're just going to start with 2D for a minute, so we're going to ignore that z for a second, and I'm just going to print out 10 and 10 to the screen. Now since we're dealing with 3D, the origin of a 3D scene is going to be the center point of the screen. That is going to be the center where all of our axes converge, and we are going to print out our 0, 0 point at 120 and 68 on the screen. So we have to shift everything over 120 pixels and down 68 pixels, and then I'm just going to use the color 12 to print that out as a white pixel. So let's just start with 0, 0, and as again we'll be ignoring the z value, and if I run it we get a pixel in the center of the screen. And if I make it 150 and run it, I'll get the pixel down here. So from the center point over 100 and down 50. So when we're working with our axis, our x-axis is horizontal across the screen, the y-axis is vertical, and we're going to introduce the z-axis now, which is depth, and the z-axis is going to go positive into the screen. So the bigger the z number gets, the further away something is going to be from us on the screen. So 0 z is going to be essentially our viewpoint, so we'll want to make sure that this isn't 0 so that it doesn't go behind our scene. So I'm just going to make this 1 for the second, and we're going to introduce this perspective. So what this does is, as the further a point moves into the screen, we should see it change its position on the screen. So to do this, I'm going to do point.z, so I'm going to take the x value and divide it by the z value, and I'm going to take the y value and divide that by the z value. So if we stick with this one, and maybe I'll make y equal to minus 50, put it up here, and if I start to increase z, meaning that point travels further into the screen, you'll see that it converges on the center of the screen. So what I'm going to do here is every time tick is called, it clears the screen, sets t equal to time, creates this point and plots it. So I'm just going to make this equal to time. That was a bit too quick. So I'm going to maybe divide this by 100, and you can see that, slow it down another bit. You see that it starts here, and the further that travels back into the screen, the closer it gets to the center of the screen. So eventually, as that travels away, it will eventually converge to the center point of the screen. So that is kind of like the old Starfield screensaver on Windows, where you'd see all the stars flying at you, and that is essentially a star flying away from us. So we could do that in reverse. So what I'm going to do is I'm going to actually start this at 10 points back. I'm going to subtract t so that it will actually get closer to us, and we can see that kind of a star effect where the star shoots off as it flies past us in space. And all of this is done just by taking an x and a y coordinate and dividing it by the z coordinate. So there's some things we'll have to be careful of. If I set it to 0, 0 will essentially be at our viewpoint, so we won't see it. And again, we want to ideally avoid dividing by 0. So the next thing that I'm going to do is I'm going to take a look at how we can turn that from a point. We're going to turn it into a circle. So I have to add a radius, maybe add a radius of 4. And we'll take a look at that. So when we add a point like this, it's going to be, so we want this to be a circle, and we want to add that kind of depth effect to it. And we simply do that by drawing multiple circles. So what I'm going to do here is I'm going to have a for loop that goes from j equals 0 to 2, and I'm going to change it so that it gives us a slight change position. So I'm going to minus j and minus j divided by 2, and you see here that we get some multiple circles drawn. The next thing I need to do is I need to change the color, so I'm going to subtract j from the color, and we can see that we're getting somewhere now. And the one thing left is the radius. So the radius in this case, I'll say, is 4, and I need to subtract j as well there, make it 3, and that gives us a grey ball with a little bit of a spotlight on it. So I'm simply drawing circle 3 times, 0, 1 and 2 for the j values, and that just draws a grey circle, a lighter grey circle, and then a white circle. But obviously as the circles get smaller, they get blockier, and the smaller one ends up looking like a square, or ends up looking like a cross. But you can see it gives us that slight illusion of having some shine on it. Now, one thing that we could do is we could change the radius of this based on the z component here. So we could make this 10. So we could do some changes here. So I'm just going to make this maybe 10 minus point dot z, and then if we change the depth as this gets closer to the screen, it will be bigger, and as it moves further into the screen, it will get smaller, and we can see, obviously, if we go too far, the point will result in a negative radius, and a negative radius will result in a circle of radius 0 being drawn, which means it's not going to draw a circle. But that gives you a rough idea of how we can scale that a bit. So and if I just add in the time again, you can see that it will get bigger as it moves towards us. So that's just to show an idea of how we can modify the depth of it with this. Now, that 10 minus point.z is the thing that will change the size of our point based on the z value. So we're not going to use that for the voxel cube. That's just something that you can use to demonstrate it yourself. And the reason for that is that the difference in size between the front and the back of the voxel cube, even if it's just 1 or 2 pixels, really kind of disturbs the perspective effect when you actually have them so close together. So you can play around with it if you want, but it's not something that's essential. I am, however, going to keep the general shininess of our voxel. Next thing I need to do is not just create one point, but create multiple points. And this lets us, and this leads us to another Lua table, in this case called points. And what I'm going to do with this is, instead of manually writing out x, y, and z points like this, I'm going to use a for loop to generate the point for me. So to create a point in to create a point, we need to insert it into the table. So table.insert is built into Lua, and it allows us to insert something into a table. So in this case, the first parameter is the table into which I want to insert something, and then I'm going to x equals 10, y equals 10, and z equals 10. So just set that up as our basic point, and don't forget to close off the bracket. So what I need to do now is, instead of inserting this manually and typing it in, I want to use for loops to generate each of the points for this. So for example, x equals, say, minus 25 to 25 in steps of 5, and then maybe x equals minus 25 to plus 25 in steps of 5, and y equals minus 25 to 25 in steps of 5, and then we'll do our end. Now this, I'm just going to split over 2 lines so it's a bit more readable, and instead of typing in x, y, and z, I'm going to actually make it equal to the values of these variables from the for loop. So this is going to go from minus 25 to 25 in steps of 5, minus 25 to 25 in steps of 5 for x, y, and z, apologies, x, y, and z. And then I'm going to, in this table, the key x is going to be equal to the value from that x variable at the point in which we insert it into the table, and the same for y and z. So it might look a bit confusing with both the values, with both of them being x, but this is the key and this will give us the value. So this is going to essentially do what we did on day 9 with the shade bob, where we created a square in 2D, and now we're actually just creating that square in 3D because we've just added an extra axis z, and that should take that nicely into the 3rd dimension for us. So now we have our points inserted into the table. Now we have to actually draw them individually. So we have the code here for drawing one point, and that's not quite good enough for us. So what we need to do is we need a for loop down here as well to iterate over every point. So for I equals 1 to points, do, and I'll just put in the end down here and indent this slightly for readability. Instead of point now, it's points I for every one of these. And that should iterate for each point from 1 to points, and then for each point it will draw it as a circle. So let's see what this looks like. Okay, so we're getting a square. We can see here it is in fact a square. It could be a cube, but we're going to have to expand it a bit to see if it is. So what we want to do is maybe multiply this by a number, maybe 600 and 600, and we'll run that. So we're actually in the middle of our cube by the looks of it. So what I'm going to do is I'm going to add a value to Z here to push it back further into the screen. So you can see now that we in fact do have our cube. So what we can see with that now is that that's being drawn, but it's actually being drawn back to front. So these guys at the front of the cube are being drawn first because they are minus values, and then the ones further away are being drawn last, so they're being technically drawn on top of it. So what we can do is we can actually sort these points so that they're drawn from the front to the back. So if we take a look here at the Z values, they start at minus 25 to 25. So minus 25 is back towards us, so they get drawn first. Then 25 will get drawn last. They're further into the screen and they are going to be drawn last, but since we're drawing to the screen on top of the previous thing, they will be on top, so it'll look strange. So thankfully Lua has a built-in sort function, so this will be one of the differences between PICO-8, and we'll take a look at it in a bit. B.Z, and we see now that our cube is being drawn in the correct manner. So I'm just going to mess around with these numbers a bit and see if I can get that cube looking a bit better. Maybe like that, just looks a bit better. So we can see our lines going back, and that in fact is our 3D cube. So the thing that's left to do at this point is to add the rotation. So for the rotation code, I'm going to pop it in as functions up above the tick function. So this function is called rotate y. It takes a point P and an angle that we are going to use to rotate our cube around. So up here I'm going to make angle equal to 0, and inside tick 80 angle equals angle plus 0.1. Okay, so we need an angle that we're going to rotate around. We'll start at 0 and we'll take it from there. So let's see, we have our rotation function. So this takes a point P and it takes the values of that point P, and it'll take the, since we're rotating it around the y-axis, the y values will stay the same, so the height of any of them doesn't change when they're being rotated in their pixels or in their points. They might be drawn to the screen when we divide for perspective at a slightly different height, but that's not the point, that's the projection separately. So p.x multiplied by the cosine of the angle minus p.z times the sine of the angle. Y stays the same, p.x times the sine of the angle plus p.z times the cosine of the angle. And that's fairly similar to our rotation code that we were looking at on day 8. So x equals x plus t, y equals y plus y equals yt, z equals zt, and this creates our little table and it returns it to us. So now we need to rotate these points before we put them into the table, because we'll put them into the table and then we'll sort them. So what we want to do is So P equals rotate Y, and I'm going to pass in these original values, X equals X, Y equals Y, and Z equals Z, and I'm going to give it the angle, and then that gives us back P, which is the point that has been rotated. So I'm just going to change this to P.X, P.Y, P.Z, and if I run it, we'll see that we now have a rotating cube. Slightly too fast. Slightly too fast, so we'll slow that down, and you can see that as the points drop back, they're lower on the screen or higher on the screen. They'll all converge to 0 as we go. So if we want to rotate another point, I can use P again and rotate X, P, angle. Now that rotate X code, I'm going to pop in here. Now we see that it is rotating on those two axes. And just for the sake of completion, I'll pop in the Z rotation code as well. So you can see for the rotate X, the X coordinate doesn't move. For rotate Z, the Z coordinate doesn't move. And I will add one more rotation here. P equals rotate Z, P, and now we should have our cube rotating on all three axes. So now we'll take a look at the PICO-8 code. So you can see that I have my rotate, Y, X and Z the exact same as in PICO-80, and the angle obviously is going to be in turns instead of radians, and the main issue here is that I also have to provide my own sort function. So let's just take a look at the code in general first. I still have points, I have angle, and I have my for loops. I'm rotating the points and I am adding them. So PICO-8 has a function, instead of table.insert, you can just use add. You still need to include the table name, and then it's the same. So it works the same, except you can just use add. Then at this point I have to call the Z sort function that I've actually provided here, and then everything else works the same. Obviously we're on PICO-8, so there will be some differences in terms of the performance. So if I just go straight off and make that the same as the PICO-80, it's going to reduce down to 15 frames or even worse. And there are some clever tricks you can use to increase the performance on this. So let's take a look at what's actually happening in this sort function. It visits every point, and while the point is less than the other point, it swaps the points. So that's basically it. It goes through the array, or it goes through the table and compares the points and swaps them. So not the most efficient sort, but it'll do for the small amount of points that we have here. So for more details on the challenge and a different expert challenge, make sure to check out the website. Best of luck.